So, if you spent any time at all in the world of machine learning, you've probably heard the terms loss function and cost function. A lot of times, people use them like they're the same thing, but they're not. And honestly, getting the difference between them is kind of the key to understanding how a machine really learns anything at all. It's the biggest question, isn't it? We say things like AI's learning, but what's actually happening under the hood? It's not some kind of magic. It's actually a pretty straightforward process of trying something, failing, and, well, measuring just how badly you failed. And this right here is the absolute bedrock of it all. The model makes a guess. Let's say it looks at a picture of your golden retriever and says, "That's a cat." For that one single guess, it gets a score, a penalty, really, telling it just how wrong it was. And this whole scoring system is where we meet our first big idea. All right, so we're starting at the most zoomed-in level you can get, the loss function. I want you to think of this as our microscope. We're going to use it to look at one specific mistake, up close and personal. So the most important words on this slide are right there at the end, a single training example. That's it. A loss function could not care less about how the model is doing overall. It has tunnel vision. It's laser focused on one data point, asking one simple question: for this one picture, how badly did we mess up? And this is the perfect way to picture it. The loss function is like a teacher who's grading one student's test. They're going question by question, marking them right or wrong, and then they tally up a score for just that one paper. It's a completely individual assessment. Now, don't worry, you don't need to memorize this list. The real takeaway here is just to see that there's more than one way to grade a mistake. You know, trying to predict a house price is a totally different problem than trying to figure out if an email is spam or not. So naturally, you're going to need a different kind of grading system, a different loss function for each job. Okay, so loss is our microscope for looking at one tiny error. But what if we want to know how the whole class is doing? How is the model performing in general? Well, for that, we need to zoom out, way out. It's time to put down the microscope and pick up the telescope. Let's talk about the cost function. And there it is, the big difference. The cost function takes every single one of those individual loss scores from every single prediction, and it averages them all out. So we're not talking about one photo anymore. We're talking about the overall performance across the entire collection of data. So let's go back to our classroom. The cost function is the teacher. After they've graded every single student's paper, punching all those scores into a spreadsheet to figure out the class average. It tells you, on the whole, how the entire class did. It's the big picture number. So at this point, you might be thinking, okay, I get it. One's micro, one's macro. Fine. But why are we spending so much time on this? Why is this such a big deal? Well, it's a huge deal because this distinction is at the very heart of how a model actually gets better. This chart lays it all out pretty clearly, but I want you to look at that bottom row, the one that says usage. A single loss score helps the model make a tiny little tweak for just one example. But the model's actual goal is to get the cost to go down. That's the average error. That one single number, the cost, is what the entire model is trying to shrink. It's the final grade on its report card. So let's just lock this in one more time, because it's so important. Loss is the microscope. It's for getting up close and personal with individual mistakes. Cost is the telescope. It's for judging the overall performance from way up high. And you absolutely need both to build a good model. So how does this actually work? Well, it's just a loop that runs over and over and over. First, the model calculates its overall grade. That's the cost. Then it uses a really clever bit of math to ask itself, okay, if I were to just nudge all my internal settings a tiny, tiny bit, which way would make my final score go down the fastest? It finds that direction, takes one small step, and then it does the whole thing again. And it repeats this, maybe millions of times, always chasing a lower and lower cost. And this is really why it all matters. That cost function is the North Star for the whole training process. It tells the model which way to go to get better. But when things aren't working right, we can grab our microscope, the loss function, and zoom in on specific examples to figure out exactly where and why the model is getting confused.
So we've looked through the microscope and the telescope. We've seen the single test paper and the final class average. Let's just wrap this all up with one final super clear idea.
This pretty much says it all, doesn't it? Loss is for diagnosis, finding the specific stumble. Cost is for evaluation, getting the final grade. And really, truly understanding that difference is a massive step toward understanding how this whole AI thing actually works.
So now you know how an AI gets its report card. It's not so mysterious, right? But it kind of makes you think. If you were in charge of the curriculum, what would be the next big test you'd want to see AI pass? What's the next challenge we should give it? Something to chew on.